Dart School presents Maths Rules. In an open number sentence, a blank or a box is used to indicate a missing number. For example, 4 plus 2 is equal to, and then if you have a box on the other side, this math sentence becomes an open math sentence in the sense that this box is open to accept a value inside it. Similarly, the math sentence 15 plus a box is equal to 20 is also an open sentence because this box is open to accepting a value. On the other hand, consider the sentence 3 times 8 is equal to 24. This is called a closed sentence because everything in this math sentence is given. The only thing that you could do is say if this is right or wrong, if this is true or false. So a closed sentence is either true or false. In this case, this is true because 3 times 8 is indeed equal to 24. So this is true. But on the other hand, consider the closed sentence 10 minus 4 is equal to 5. Now this is not right. The left hand side is 6. 10 minus 4 is 6 and that's not equal to 5. Therefore, this closed sentence is false. So let me write down the names. This one's called an open number sentence. And this one's called a closed number sentence. Let's now talk about a few important rules that we often use in maths. And the first rule, let's call that rule 1, tells us that in addition and multiplication, the order in which we add or multiply numbers don't matter. So order does not matter. Consider the addition sentence 10 plus 2 plus 3. This is equal to 15, right? Now if you change the order of the numbers in this addition sentence, let's say 2 plus 10 plus 3, that's also 15, right? Or for that matter, 3 plus 2 plus 10 is also equal to 15. So in addition, the order in which you add the numbers don't really matter. You still get the same answer. And the same goes with multiplication. Consider 3 times 4. That's 12. And isn't that equal to 4 times 3? That's also 12, right? So the order doesn't matter. And you could also try this with 3 or more numbers. Let's try with 3 numbers. 2 times 3 times 5. 2 times 3 is 6. And 6 times 5 is 30. And that's the same as, let's just change the order, 3 times 5 times 2. 3 times 5 is 15, times 2 is 30. So you are free to multiply numbers in any order. You still get the same answer. Rule 2 tells us that in addition and multiplication, the numbers can be grouped in any order. So let's write that down. The numbers can be grouped in any order. And that actually has a name to it. It's called the associative property of addition and multiplication. Associative property. Rule 1, in addition and multiplication, order doesn't matter, is also called the commutative property. Commutative property of addition and commutative property of multiplication. Okay, so back to the associative property. What does it tell us? It tells us that you can group numbers in an addition or a multiplication sentence in any way. In other words, if you have, let's say, 19 plus 11 plus 45, you could change the grouping and change it to 19 plus 11 in one group plus 45. And why would you do that? So that the calculation becomes easier for you. 19 plus 11, this 9 and this 1, they add up to 10, and you want to take advantage of that to do this problem mentally. Note that the overall ordering of the numbers is still the same. 19, then 11, then 45. 19, then 11, then 45. That's what the associative property is about. If you wanted to change the order of the numbers, then that would call for applying the commutative property. Similarly, in multiplication, let's say you want to do the multiplication 23 times 2 and times that with 5. That doesn't seem to be the easiest problems in the world until you suddenly notice that, hey, I could apply the associative property and change the grouping. Instead of putting 23 and 2 in one group or in one parenthesis, I could take the 23 out and then put the 2 and the 5 in one group. And we all know that 2 times 5 is 10. So this is going to be equal to 23 times 10. And who doesn't know that multiplying a number with 10 means adding a 0 to the end of the number? So the answer is 230. Easily done. That's why we use the associative property. Rule 3 is about breaking apart a number in a multiplication or a division sentence. Let me show you how that helps. Let's say you want to multiply 8 with 17. You don't know what 8 times 17 is, but you certainly know what 8 times 10 and 8 times 7 is. So break this 17 apart into two parts, 10 and a 7. 10 plus 7 is 17, and multiply each one of them with 8. And then add the two answers. 10 times 8 is 80, plus 7 times 8 is 56. So 8 times 17 is the same as 80 plus 56, which is 136. Similarly, 3 times 29 is the same as, you could rewrite the 29 as a 30 minus 1. So it will be the same as 30 times 3 minus 1 times 3. 30 times 3 is 90, easy. 3 times 3 with a 0 in the end, minus 3 times 1 or 1 times 3 is 3. So this answer is 87. 3 times 29 is 87. Easily done in your head. And you could actually do the same thing with division as well. Imagine trying to do, let's say, 84 divided with 4 in your head. You could break down the 84 into a 40 plus 40 plus 4. 40 plus 40 is 80 plus 4 is 84. And then go on to divide each one of them with 4. And add the answers. So 40 divided with 4 is 10. 40 divided with 4 is 10. 4 divided with 4 is 1. So this answer is 21. And in the same way, 95 divided with 5 is the same as 100 minus 5 divided with 5. Divide each one of the numbers with 5. 100 divided with 5 is 20, minus 5 divided with 5 is 1. 20 minus 1 is 19. And by the way, this property, this rule 3, is called the distributive property. Of multiplication and division. So the associative property, the commutative property, and the distributive property are three very useful properties that you will often need in solving your math problems.